for being here. Today I'm going to be talking about voice programming, sort of a basic how-to. A little bit about my background in voice programming. Back in 2012, I was working at an insurance company doing billing. Lots of typing, lots of invoices, lots of emails, lots of clicks. Long story short, I ended up with RSI in my hands and wrists. And that has sort of unfortunately stuck with me as I transitioned into a career as a programmer. And about a year ago, I saw a video of a talk given by someone named Tavis Rudd at PyCon 2013, where he basically used Emacs to program by voice. I thought I would give it a shot. And yeah, it's a year later, and I don't use it all the time, but maybe a third of the time I code by voice. It helps, takes a lot of the stress off my hands and wrists. So why program by voice? RSI sucks. Any sort of disability that prevents you from typing, editing text sucks. And really the best way to help yourself heal is to not type, which is hard if you're a programmer. So the next best thing I found is to just talk. It's not faster than just typing. So if you're looking primarily just to speed up your workflow, that's not what this is for. But even if you are 75% as effective at editing text by voice as you are by hand, that's better than 0% because your hands and wrists hurt too much. So the basic idea, at least how I use it, is I have a bunch of little small atomic words, and I combine them in a, I guess, a Vim-like fashion to do sort of really powerful editing things. So as you can see, copy pair will take all of the text inside a pair of parentheses and send it to your clipboard. Bill Coup2 moves the cursor back to the second occurrence of the letter C. I'm actually going to table the demonstration for now. It was running a little bit long with the demonstration in there. If you'd like to see it, please come up to me after this talk, and I'd be happy to show you. All right, so the tooling and sort of how to get it set up. There are really 4 main components to a voice programming system. And they are awesome. So the 4 main components to a voice programming system. The first one, you need some sort of software that converts your text into, or that converts your speech, the sound that you give it, into text. This is really where the heavy lifting comes. The second part is how do you get, okay, you have this text, how do you get it into your programming environment? It sounds simple, but a lot of engines weren't designed for developers in mind. So occasionally it's easier said than done. The third component is, okay, you have this text, it's in your programming development environment. Now how do you do something useful with it? And finally, you need a fairly extensible editor that is capable of handling these requirements. So the current state of affairs is Dragon Naturally Speaking is a commercial speech-to-text engine. I think it retails for, well, I checked on Amazon about an hour ago. It's $30. It's definitely the most accurate, probably the easiest to get set up and going with. The second component, there's a program called Natlink. It's been around a long time, I think 15, 16 years. And it is used, basically it injects itself into Dragon Naturally Speaking and sort of pulls that text. So what usually happens with Dragon Naturally Speaking is text gets sent to whatever application you have currently open. So, you know, if you're in a text editor and you say, you know, back, you don't want the words back appearing on your screen. You want to move back by some arbitrary amount. And that's what Natlink lets you do. So the third component, Natlink, basically you write grammar classes which are essentially hold rules, which are similar to regular expression patterns. based on whether that text matches with a regular expression pattern. You can trigger a callback function. You can send arbitrary keystrokes to whatever application you have open, click the mouse wherever on the screen. And then finally, you need the text editor that's extensible. Vim and Emacs are the big two. My approach is actually pretty similar. However, I wasn't comfortable using Natlink. It's a great software. I highly recommend it if you're comfortable with the fact that Dragon, naturally speaking, is a closed source proprietary program. And I wasn't comfortable using a program that basically hacked into the event loop of Dragon, naturally speaking, in lieu of their $600 professional edition, which does the same thing. So far, Nuance, which is the company that owns Dragon, naturally speaking, seems to be fine with it. But in case they're not, I didn't want my entire stack based on sort of relying on their continued goodwill. So I use a program called Panacea, which I wrote. Basically, it runs in a virtual machine, and it's just a little GUI window, which catches text that gets sent to it from Dragon, naturally speaking, shuttles it along to your main system, either through sockets or through a shared directory. Once it's there, similar to Natlink, there are grammar classes that you can use to, again, match patterns to text. And then finally, I use a open source text editor called Atom. I guess the best way I would describe it is like an open source web-based version of Sublime Text. So these are really the four engines that can be used in a speech development environment. I've talked a decent amount about Dragon, naturally speaking. Windows speech recognition actually has a speech-to-text engine built into it that can be accessed through .NET. It's pretty good, not as accurate as naturally speaking, but if you don't want to use naturally speaking for whatever reason, that's a pretty good alternative. CMU Sphinx is open source, developed at Carnegie Mellon. Unfortunately, it doesn't have the financial backing of any multi-billion-dollar companies, and it shows in terms of accuracy and ease of configuration. Finally, a bit of a novelty, there's the Web Speech API, which is currently only implemented in Google Chrome. You say something, you have an instance of Chrome open through some client-side JavaScript. What you said gets sent off to some Google server somewhere. That Google server translates what you said, sends it back a couple seconds later. Kind of cool, but I don't know if I would rely on it being around in a couple of years. OK, so the second part, the method to transfer text to your programming environment. In Windows, unfortunately, Dragon, naturally speaking, only runs in Windows. So you can use Natlink to, again, get the text. Alternatively, you can use the approach I mentioned before, where you have a virtual machine running Windows with Dragon, naturally speaking, inside of it. Third approach is Windows 10 introduced something called virtual desktops, which for any Linux users out there is basically workspaces. You can run Dragon, naturally speaking, inside of that, have your own little GUI window inside of that as well, and then send it along to the rest of your environment. OK, third part. OK, you have the text. Now how do you do something useful with it? So grammar classes allow you to basically collect rules together, which actually in Panacea are just get compiled down to regular expression patterns. As an example, the first one, copy, will match, as you can probably guess, copy followed by either left or right or up or down, followed optionally by a number. Camel, followed by anything. So camel, hello world will match. One of the cool things about grammars is that the way they're structured in Panacea, you can use them, you can subclass them to sort of organize your environment by text editor, by language, any other context you can think of. So here's a bare bones grammar example. The rules are in the self.mapping dictionary there. So if it gets say hello, it'll send hello world to whatever application you currently have running. If it gets say goodbye followed by any number, it will call the self.goodbye method, which executes that. Finally, the fourth component. I'm not going to get too much into it. I don't want to ignite any language wars. I'll just say Vim and Emacs are two very good editors, and Vim's probably, if you want to get started like today, Vim's probably your best bet in that the commands that you use the commands that you use in Vim map very well to sort of the atomic commands that you use to program by voice. So for instance, my previous example, bilku2, in Vim, that would be 2 capital T lowercase c. Emacs, very powerful. You have to put a lot of time and effort into it. You probably know already if that's something you want to do or not. And finally, the editor I use is called Atom. Again, JavaScript, open source. There's a lot of niceness built into it, and you know, it's also got a Vim mode if you want to take that approach. So a couple of issues that you run into, programming in general, as well as voice programming, is what to name things. You don't want too many words sort of cluttering up your global namespace, because you want to reserve as many words as possible for just, you know, if you say apple, you usually want the word apple to appear on your screen. You don't want to do some random esoteric thing. So I reserve words like left, right, copy, delete for, you know, moving left, moving right. And then for sort of less common things, I try to bundle them together based on common functionality. So for instance, Vim has a plugin called NerdTree, which is basically a file system tree on your screen. And you can do things like create new files, copy files. And instead of just creating some sort of random word for commands like, you know, create a new file in NerdTree or copy a new file in NerdTree, I say nerd new, nerd copy, nerd delete. And that's doesn't pollute my global namespace, and it's just easier to remember. One other thing that I think is pretty cool is using basically modal editing, where you sort of on the fly load grammars based on whether you're working in a certain framework, whether you're working with a certain language. So for instance, if I am doing regular Python and I say, you know, new model field, the words new model field will appear in my text editor. But then if I say enable Django, and then I say new model field, it will do, you know, models dot integer field. And then I can say disable Django, and then it's back, and then all those grammars get unloaded, and it's back to how it was before. Another issue is accuracy. Speech-to-text engines are very reliant on context of what you're saying. So for instance, if I say salt and Pfeiffer, it will hear the words salt and it will assume almost always that I said pepper at the end, even though Pfeiffer sounds nothing like pepper. So when you're programming, you're saying a lot of really weird, disjointed things. So it tries to guess what you're saying a lot of the time, and it's wrong very frequently. So one approach that I have to sort of, I guess is harm reduction for that, is the homophone tag, where I basically say, okay, if it gets a word in a certain part of our rule pattern, just pretend like it heard this other word. So for instance, I have this homophone dictionary where I have the word line, and then I have a rule that says, okay, copy homophone line. So if it gets the text, you know, copy line, or if it gets the text copy wine, or if it gets the text copy fine, just pretend it got copy line. Finally, you don't just have to edit text. With voice programming, you can browse the internet. There are Vim-like plugins for, I believe, Chrome and Firefox, so you waste time online and not have to hurt your hands in the process. You can you know, interact with any keyboard-based program. You know, let your imagination run wild. And finally, turn-based games. I occasionally play a game called Heroes of Might and Magic 3, which is sort of a combination of a real-time strategy, not real-time strategy, a strategy game and a role-playing game. Involves a lot of clicking in arbitrary locations on the screen, and it can be a little repetitive, so I have commands that sort of help me speed up that process. Finally, RSI sucks. If you have it, do something about it. It's only going to get worse. Yeah, thanks for listening. Well, probably the biggest challenge, aside from configuration, so getting the virtual machine running, getting the speech engine to work on the virtual machine, getting the USB microphone to work with the virtual machine with the speech engine. Other than that was probably the accuracy issue. So that was where the homophone tag comes in.
You mentioned that a lot of the speech systems are dependent on saying salt and pepper. They're trying to predict what the next word is going to be. Could you load up a bunch of, I guess, Python terminology and have the software predict the next likely word for programming?
Probably. Yeah, I mean, you can in your grammars really specify it however you want. So if you get a couple words beforehand, you can say, all right, expect any of these words here.
This language, like, from what I can tell, the wine line thing is like the language model of the speech recognizer correcting stuff to things that should be normal. Yeah. Do you have like a collection of things that you say so we can build a language model that is specific to, like, I want to do voice programming?
So what I have is basically a bunch of grammar classes, which hold basically the things I say plus whatever else my engine tries to recognize as those things. So yeah, like your example, wine line. Yeah, they're on GitHub. Just look them up.
When you enter a command, do you have to say enter afterwards? Or
oh no, it just you just stop talking for half a second. And
even when it's waiting for a potential other parameter, like a number at the end?
So if it doesn't match any of the rules, it will just print out what you said by default.
Okay.
So for instance, the example, hello world, if you just say hello and then pause for like half a second, it'll print out hello.
But if you were in the one where it was like copy left and then there's an optional number afterwards, if
right.
you just say copy left, is there a default that it's going with? Or
so you can link that to a function, and you can just say, okay, if there's no number, because the functions that you get by default get a words parameter, and those words are basically the words that you said. So if you can say, oh, if there's no number at the end of my words list, just treat it as though it got 1.
And then it's just some kind of delay that if it doesn't get a number after some amount of time?
Yeah, or if, so that's on the speech engine part where it just says, okay, basically it doesn't do anything as long as you're talking. Once you stop talking, it will send all that text that it got out.
How many grammars do you have defined, like custom grammars? And does it take more and more time the more grammars you add?
I would say I probably have not as many as you might expect. I have a Vim, not a Vim folder. I used to have a Vim folder. I have an Atom folder now, which holds probably maybe a dozen separate grammars. And then inside that, I have a Python folder, specifically when I'm programming in Python, that has maybe 8, 10 grammars, something like that.
Which systems are you using?
Oh, sorry. It's linear, like the number of patterns it checks. It grows linearly, but I have not run into any sort of performance issues with it.
Which systems are you running on, and what virtual environment?
Yeah. So I'm running on my host machine is Linux Mint. I have VM, basically a virtual machine from Windows or from Microsoft, and that is running Windows 7. Windows 7 is running Dragon Naturally Speaking, and then basically Panacea is picking that up and sending it along to my main system.
We have 2 more minutes if anybody's got.
Yeah, I mean, any program that can be controlled primarily by keys can be controlled by voice. You mean like dictating? They're much better at dictating text than they are at getting arbitrary words and trying to recognize those words without any sort of context. So dictation alone, it's actually gotten to a point where its accuracy is in the high 90s. All right. Cool. Thanks, everyone.